In section 6.2, we look at the ellipse. Let's start with the definition. An ellipse is the set of all points in a plane such that the sum of the distances of those points from two given fixed points is equal to a fixed positive number. Each of the fixed points is called a focus, and together we call them the foci. Foci is just plural of focus. Basically, the shape of an ellipse is what you might call an oval. So the way that we get it is we start with two fixed points called the foci. So we have one of those fixed points here and the other one here. And we've labeled those F1 and F2. And then the ellipse is the set of all points such that if you take the distance here plus the distance here, you always get a constant. And so you can see that we call this distance D1, we call this distance D2, and D1 plus D2 is some constant number that we call D. So going around this ellipse, no matter where we pick a point on this ellipse, if we take the distance here plus the distance here, it's always equal to this number D, no matter where we go. So if I take a point down here, this distance here plus this distance here will be equal to D. This is how we get an ellipse. And it turns out that this shape, this ellipse, is really important because all of the planets go around the sun in what we call an elliptical pattern. Let's talk about a few more important features for the ellipse. So here we have our ellipse, which is this oval shape. You'll notice that it's longer here and it's shorter here. So it's kind of like a circle, except that it's not the same distance across. So here we have the center of the ellipse, and then this longer line that connects the two sides of the ellipse is what we call the major axis. And this shorter line here is called the minor axis. And the major and minor axes are perpendicular to each other. And the foci, the two given fixed points in the beginning, those always lie on the major axis. So what we want to do is talk about how do you get the equation of an ellipse? How do you describe this set of points in the plane? And we won't bother with deriving this, but let's go ahead and take a look at the equations. So for this, we have two possibilities. One possibility is that our ellipse is what you might call horizontal, or at least it has a horizontal major axis. That is this shape here. The other possibility is that it has a vertical major axis, which means it has this shape here. For these equations, we are assuming the center is at the point 0, 0 for both of these. And we are going to assume that the coordinates of the major axis, these points here and here, correspond to the points A0 and negative A0. And on the other ellipse over here, they correspond to 0A and 0, negative A. This should be a negative there. There we go. So basically, A refers to this distance here, or in this case, A refers to this distance here. And then there is another number that we call B, and that corresponds to the minor axis, the shorter axis, which is this length right here. So this length here is B, and in this ellipse over here, this length is B. So given those parameters, the equation of the ellipse is either x squared over a squared plus y squared over b squared is equal to 1, or x squared over b squared plus y squared over a squared is equal to 1. So you'll notice that these two equations are very similar, but the key thing to remember is a is always bigger than b, right? Because a refers to the length of the major axis here, right? So half of that is a. And b refers to the length of the minor axis. Half of that is b. And so since we know the major axis is longer than the minor axis, we know that A is always bigger than B in both cases. So if you know that A is bigger than B, if the bigger number is below the x squared, then you know it's a horizontal ellipse. And if the bigger number is below the y squared, then you know it is a vertical ellipse. Now the other thing we need to talk about are the foci. To get the foci, we need the coordinates of these points here. And to get those coordinates, we need to know the value of this number, which we call c. And it's the same in either case. This is c here. And to get the value of c, we know that c is equal to the square root of a squared minus b squared. And that's true for both of these. Let's go ahead and take a look at an example. So let's consider the ellipse that is centered at the origin and defined by the equations 16x squared plus 25y squared equals 400. First, we want to write the equation of the ellipse in standard form and determine the orientation of the major axis. Then we need to find the coordinates of the vertices and the foci. And then finally sketch the ellipse and indicate the vertices and the foci. So the first thing I want to point out, if we go back to the previous page, is that in either case, whether it's a horizontal ellipse or a vertical ellipse, notice that you want it to be equal to 1 on the other side. So the first thing I'm going to do in this particular equation, 16x squared plus 25y squared is equal to 400, is I'm going to get 1 here, and I do that by dividing both sides by 400. So that amounts to just dividing everything by 400. Now, when you do 16 divided by 400, we know that 16 goes into 400 25 times. So this becomes x squared over 25. 25 goes into 400 16 times. And so this is y squared over 16 is equal to 1. And this can be rewritten as x squared over 5 squared plus y squared over 4 squared is equal to 1. So clearly you can see that the larger of these two numbers is under the x, and that means that this is a horizontally situated ellipse. That means that the major axis is horizontal. So we have taken care of part A. We have the equation in standard form, and we know that it is horizontally situated. For part B, we want to find the coordinates of the vertices and the foci. Okay, so to do this, I'm going to actually start sketching the graph. So I'm going to do part C first, sketch the graph, and then we'll come back and talk about the vertices and the foci. So first of all, we know that the center of this ellipse is at the origin, and we know that this number here is A, so we have A equals 5, and this number here is B, that's B equals 4. So that means from the center, we're going to go 5 units to the right and 5 units to the left, and then 4 units up and 4 units down. And our ellipse is just basically an oval-shaped graph through these 4 points. So you just do your best to kind of sketch the ellipse here. Now, the 2 points on the end of the major axis, these 2 points right here, which are the points -5, 0, and 5, 0, those are what we call the vertices. So up here in part B, they asked for the coordinates of the vertices. So one vertex is -5, 0. I'll call that V2. And the other vertex, which I will call V1, is 5, 0. Now we need the coordinates of the foci. Now we know the foci are going to be somewhere on this major axis, and we know that they are going to occur c units from the center. So we need to calculate the value of c. Now we know that c is equal to the square root of a squared minus b squared. So for this problem, that's the square root of 25 minus 16, which is the square root of 9, and so we know that c is equal to 3. So what that means is from the center, we're going to go 3 units to the right and 3 units to the left, and those are our foci. So here's focus 1, here is focus 2, and as I mentioned earlier, this is vertex 1 and vertex 2. So the coordinates of those foci, focus 2 is -3, 0, and focus 1 is +3, 0. And so now I've done everything that they've asked me to do. Here's another example. Determine the equation in standard form of the ellipse with center at the origin, one focus at the point 0, -3/2, and one vertex at 0, 2, and then sketch the ellipse. I'm actually going to start with sketching the ellipse first. So first, let's go ahead and take note that the center is at the origin, and it tells us that one vertex is at 0, 2, and one focus is at 0, -3/2, which is right about here. And now we want to find the equation of the ellipse. Well, here's the thing. If this vertex is 2 units above the center, then there will be another vertex 2 units below the center. That will be right here. So we'll call this vertex 2, vertex 1. And if this focus is 1.5 units below the center, the other one will be 1.5 units above. And so this is the coordinates of the other focus. I'll call that F1 and F2. So really what we need to know is the length of the minor axis. We need to know the value of B. So remember, we have a relationship between A, B, and C. For this particular ellipse, it is going to be x squared over b squared plus y squared over a squared is equal to 1. And we know that a is the larger number, and we know that that is under y because our major axis is on the y-axis. It's vertical. We also know from this picture that a is equal to 2 because a is the distance from your center to your vertex. That distance is 2 units. And we also know that c is equal to 3/2 because c is the distance from the center to the focus. So we just need to find the value for b. We know that c is equal to the square root of a squared minus b squared. So that means that 3/2 is equal to the square root of 2 squared minus b squared. What I can do to solve this for b is I can square both sides. This is going to give us 9/4 on the left side and 4 take away b squared on the right side. Now I'm going to add b squared to the left side and subtract 9/4 to the right side. That's going to give us b squared equals 4 take away 9/4. Remember that 4 is 4 over 1, so if I multiply to get a common denominator, I have 16/4 take away 9/4, which is 7/4. And that means that b is equal to the square root of 7 over 2, right? Because to solve for b, we have to take the square root of both sides. And you could approximate this value, which is a good idea because since we have to graph it, we would like to know what is the square root of 7 divided by 2. And that value is approximately 1.32. Okay, so now let's go ahead and complete our graph. So for the graph, we know that the minor axis is going to be 1.32 units to the right of the center and 1.32 units to the left of the center. And I will sketch an ellipse now through those points the best that I can. So this is more or less what the ellipse looks like. And then now the final thing we need to do is finish what is the equation. So to finish the equation, all I have to do is plug in my values for a and b. We have x squared over b squared. B is square root of 7 over 2. So we're going to square that. Plus, and then we have y squared over a squared. And we know a is 2, so that's just going to be 2 squared. This is x squared over 7/4 plus y squared over 4 is equal to 1. And then finally, right here, what you can do, instead of dividing by 7/4, you can multiply x squared by 4 sevenths. So we're just multiplying by the reciprocal, and this makes it look a little bit cleaner. So here is the equation in standard form for that particular ellipse. The last consideration in this section is to just move the center of the ellipse so it's no longer at the origin. So if we move the center to be at the point HK, notice that the equation changes in the same way that the equation for the parabola changed. So now if you have a horizontally situated ellipse, the equation is x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. And if it is a vertically situated ellipse, you get the same kind of thing. The only difference is now the larger number a is under the y variable instead of the number a being under the x variable. Everything else is exactly the same. So to get the focus, we go c units to the right and to the left of the center, or in this case over here, we go c units up or c units down. And then the major and minor axes are both calculated using a and b, just like before. So let's take a look at another example. In this example, they want us to determine the equation in standard form of the ellipse with foci at 4, 1 and 4, negative 5, and one vertex at 4, 3. Also sketch the ellipse. Well, I'm going to sketch the ellipse from the beginning. Let's start with the foci. One focus is at the point 4, 1. The other focus is at the point 4, negative 5. I'll label this F1 and I'll label this F2. And then they tell us that one vertex is at the point 4, 3. 4, 3 is right here. Let's go ahead and put that in, and I will call this V1. So one thing I could do right away is I can go ahead and find out where is the second vertex. Well, if this vertex is 2 units above this focus, the other vertex will be 2 units below. So the other vertex has to be right here. Now the center will have to be exactly halfway in between these two foci. So notice the distance between y equals 1 and y equals negative 5 is 6 total units. So if we go 3 units down, this will put us directly at the center. So the center of this ellipse has an x-coordinate of 4 and a y-coordinate of negative 2. So remember, the equation for this ellipse is going to be x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And again, the reason we know a has to be under the y variable is because this is a vertically oriented ellipse. So we do know the value of h. H is 4, and we also know the value of k. K is negative 2. So this equation now looks like x minus 4 squared over b squared plus y plus 2 squared over a squared is equal to 1. So now we just need to know, what is the value of a and b? Well, we know the value of a is the distance between the center of the ellipse to either vertex. So the value of a is this distance right here, and that distance is 5 units. So we know that a equals 5. And then the distance between the center and the focus, that's this distance right here, that's 3 units, and that's the value of c, not b. So to find the value of b, we're going to use the formula c equals the square root of a squared minus b squared, and I'll just plug in the values of a and c, and then we can find the value of b. So we get 3 equals the square root of 5 squared minus b squared. This is 3 equals the square root of 25 minus b squared. If I square both sides, I get this. Adding b squared to the left side and subtracting 9 from the right side, and then taking a square root, we should find out that b is equal to 4. So now that I have the value of b and the value of a, all I have to do is plug those in to our equation, and that's going to give us x minus 4 squared over 4 squared plus y plus 2 squared over 5 squared is equal to 1. And the final thing that you should probably do here is go ahead and just write this as 16 and write the other one as 25. And now we'll just finish the sketch of what this graph should look like. So let me go ahead and erase what I don't need in here. Let's erase the center. And we know that the value of B is 4 units. So we're going to go from the center 4 units to the right and 4 units to the left. And then we can go ahead and sketch our ellipse, which should look something like this. For our final example, they want us to write the equation in standard form, defined by what you see here, and sketch the ellipse. And you'll notice what we need to do here is complete the square. So first of all, let's just take this equation and reorganize it a little bit. So 5x squared minus 30x, notice that I can factor a 5 out of that, and that will leave us with x squared minus 6x. And then I will leave room to complete the square here. Plus, and then here I can factor 25 out, and that gives us 25 times y squared plus 2y. And again, leave room to complete the square. And this will be equal to, I'm going to subtract 20 from both sides, and so it'll be equal to negative 20. Now I need to complete the square. So here I need to add the appropriate number. Remember, what to do is to take the middle number, divide it by 2, and square it. So this is going to be adding 9 here. But then now we have 5 times 9 is 45. So we have to add 45 to the other side. And here, if I take the middle number, divide it by 2, and square it, that's equal to 1. So I need to add 1 here. And on the other side, I need to add 25 because 25 times 1 is 25. Now, if we factor what we have, this one becomes 5 times the quantity x minus 3 squared. This one becomes 25 times the quantity y plus 1 squared. And on the other side, we have negative 20 plus 45 plus 25. This is equal to 50. And now to put it into standard form, I need to divide both sides by 50. Remember, because we need to have 1 here. So if we do that, we end up with x minus 3 squared over 10 plus y plus 1 squared over 2 is equal to 1. So here is the equation in standard form. Now to sketch the ellipse, we need to identify the center and the vertices and all that other good stuff. So the center of this ellipse is going to be at positive 3, negative 1. So notice that I'm just taking the opposite of each of these coordinates. We need the value of a. Well, 10 is a squared. So this means that a is the square root of 10. And if you plug the square root of 10 into a calculator, you should get about 3.2. That's helpful when it goes to graph. And then b squared is 2. And so b is going to be the square root of 2, which is approximately 1.4. And now we need c. c is going to be the square root of a squared minus b squared. This is the square root of 10 take away 2. So c is the square root of 8. The square root of 8 is 2 radical 2, and 2 radical 2 is approximately 2.8. So now let's go ahead and sketch the graph. So first of all, to sketch the graph, I'm going to start by graphing the center, which is at the point 3, negative 1. And then we know that this ellipse is horizontal because the larger number is underneath the x variable, the smaller number is underneath the y variable. So this ellipse goes sideways. From the center, we have to go a units to the right and a units to the left, and a is approximately 3.2. So if we go 3.2 units to the right and 3.2 units to the left, we get those points approximately. And then for b is 1.4. So we go up 1.4 units and we go down 1.4 units. And this is our ellipse. So notice that you can sketch the ellipse without knowing the foci. But the foci are going to be 2.8 units to the right and to the left. So 2.8 units to the right puts us right about here. 2.8 units to the left puts us right about here. So we'll call this focus 1, focus 2, vertex 1, vertex 2. And now if you want to actually find the coordinates of these things, you have to be a little bit more careful. So to find the coordinates of the first vertex, let's say, you would start with an x-coordinate of 3, but then we went radical 10 units to the left. So that x-coordinate is 3 minus radical 10, and the y-coordinate is still negative 1. For vertex 2, we started at 3 and we went radical 10 units to the right. So that would be 3 plus radical 10. Y-coordinate is still negative 1. And then for the foci, you do the same thing. So for the first focus here, we start at x equals 3, and we go 2 radical 2 units to the left. So that would be 3 minus 2 radical 2. Y-coordinate is still negative 1. And for the other focus here, we start at the center, which again is at 3, and we add 2 radical 2, and then the y-coordinate is still negative 1. So these are the precise coordinates for your vertices and for your foci. However, when it comes to graphing the ellipse, you don't really need the precise values. What you need is a decimal approximation because that's much easier to graph.